Okay, today for geometry we're going to do section 12.3, which is two-way tables. We're going to do some probability with those two-way tables. First of all, a two-way table is a frequency table. It displays data collected from one source that belong to two or more categories. So you can see an example right here. This is a survey of freshmen and sophomores, and it's whether they are attending a school concert. So this two-way table is a way to organize the results from the survey. So we surveyed the freshmen and the sophomores, and then we're finding out if they plan on attending or not attending. Right here it says each entry in the table is called a joint frequency. So the 25, the 44, the 80, the 32, those are all joint frequencies. And then the sum of the rows and the columns are called marginal frequencies. So the marginal frequencies, you would have to add together 25 plus 44, and that's going to add an extra column, which we're going to do just on this next example from scratch. But you're just going to add 25 and 44 together to find out how many total freshmen were responded to the survey in the first place. So we've got 69, and then we add the sophomores 80 and 32, and we get 112. Also, we're going to add the column itself. So 25 and 80, that's 105. And then the 44 and 32 is going to give us 76. These numbers in blue, if we go across the columns, they're going to tell us how many total people we surveyed. But if we go up and down, I'm sorry, I said across the columns. I meant across the rows. If we go up and down, that's going to tell me how many total are attending and how many total are not attending according to the survey. Now this special box at the end here is the total surveyed between the freshman and sophomore combined. So I could add this way, or I could add 105 plus 76, and I should get the same answer if I add up and down or side to side. So we're going to do that from scratch for example 1. I'm going to make a two-way table. It says that another survey similar to the one above, we've got 106 juniors and 114 seniors respond. So that's how many total respond. So that's going to go in the total column. Here's juniors, total of 106 responded, and for seniors, a total of 114 responded. Of those that responded, 42 juniors and 77 seniors plan to attend. So juniors will be 42 and seniors are 77. They're planning on attending the concert. So now we're going to find the rest of this table. We're going to find the other joint frequencies, and then we're also going to find the missing marginal frequencies. The joint are in the white, and then the marginal are in the gray. So not attending. To find out not attending, you're going to have to subtract the total, 106, minus the 42 that are attending. And when you subtract those, you should get 64 not attending. And then for seniors, we're going to take the 114 total that were surveyed, and we're going to subtract the 77 that said they are attending, and we'll get 37 are not attending. I'm going to add together 42 and 77 to find out how many total are attending the concert, and that would be 119. I'm going to add 64 and 37 together. How many are not attending is 101. And then if I add the total number attending and the total number not attending, or if I add the total number of juniors and the total number of seniors together, I'm going to get 220. So now this says find and interpret the marginal frequencies. So I found everything. Now I have to interpret. So I have to say what it means. So let's see. Let's start with 106. So 106, that is the total juniors that responded. 114 is the seniors that responded. Over here, 119 is the students that are attending the concert, and then the 101 is the students not attending. And finally, 220 is the number of students that were surveyed. I did not spell that right. Surveyed. Okay. So everything that I wrote in green, that is the marginal frequencies and interpreting those marginal frequencies. The numbers would be the frequencies, and then the words would be that interpretation. Okay. Next page says finding relative and conditional relative frequencies. We're going to start with relative frequencies. A joint relative frequency is a ratio of a frequency to, and I'm skipping some of these words, it's the ratio of the frequency over the total number of values, like over just the total number total. Looking at our past page, the 4 values that were in the white behind it, those are the frequency, joint frequencies. And if I take any of these numbers, the 220 is going to be what I'm going to put on the bottom to make that a ratio. Okay, so we're going to take the white ones and we're going to put it over 220, and that's going to be a joint relative frequency. Marginal relative frequency would be to take the values in the margins, the 106, the 114, the 119, and the 101, and put those over that total 220. And then we also are going to put the total 220 over itself 220. So we're finding the ratio of, for example, how many juniors responded out of how many total students were surveyed. So that's what we're going to do for example 2. We're going to find the joint and marginal relative frequencies. Oh, sorry, let me put this back down. Excuse me. So quickly, I'm just going to copy over the values that we had since the table is on the other page. So I had a 42, I had 64, 106, 77, 37, 114, 119, 101, and 220. Now, all of those values we're going to put over 220. Again, every single one of these putting over 220. And when you do that, the total column, the total should be a value of 1. So now what we're going to do is we're just going to use our calculator and we're going to calculate each one of these. We're going to round to 3 decimal places to, get some accuracy. And now I've already written these down to save a little bit of time on the video. I'm sure that you can divide these on your own. But when I divide 42 by 220, we get 0.191. I get 0.291. And I get 0.482. Here I'm going to get 0.35, probably 350, but 0.168, 0.518, and then 0.541, 0.459, and then 1. Now, if you were to use your calculator and add together anything across the rows or across the columns, let's say I'm going to add together the joint relative frequencies 1.191 and 0.350. I get 0.541, and you'll see that is in the total column there. So the joint relative frequencies will add together to give us the marginal relative frequency. And let's just try it across 0.191 plus 0.291, and that equals 0.482, so it works across as well. I'm going to add together the two marginal frequencies, marginal relative frequency. So 0.482 plus 0.518, and that gives us a total of 1. So those will also add to give us 1, just like it did in the other table when we were just using the joint and marginal frequencies. So these are relative joint and marginal frequencies. Okay, and then to find the conditional relative frequencies. Okay, so what we're going to do is we're going to use that information that we just got on the other table. I'm going to copy it over here in the top corner. We got 0.191, 0.291, 0.482, and we got 0.350, 0.168, this one was 0.518. Down here we had 0.541 and 0.459. Okay, so this example says, show the conditional relative frequency based on the row total. So I didn't go over the conditional relative frequency definition yet, but it's a ratio, so that means we're putting a number on top of another number. We're using division of a joint relative frequency and the marginal relative frequency. So, for example, let's see, this box right here is going to represent the frequency at which somebody who is a senior is not attending, okay? Because we're just talking about based on the row total. So this is what you're going to do. Since it's based on the row total, you're going to take the row totals and go back through the row and put that total as the bottom number. So we're going to have 0.482 right here, and go back, row total is 0.482. And then in the next row, we've got 0.518 and 0.518. So those are the row totals. You see how I did not use attending and not attending? I did not use that at all. And now if they asked you to do column totals, that's the number that we would put on the bottom for the two values in that same column. But we're doing rows, so we're going across. So you use your calculator. I've already written these down so that, oh no, I didn't write them down. Just kidding. So we're going to do it real fast. 0.191 divided by 0.482. 0.291 divided by 0.482. 0.350 divided by 0.518. And 0.168 divided by 0.518. Okay, so this particular box that I outlined, 0.324. To interpret that, I would say that given that a student is a senior, so if we already know that the student is a senior, that's where the row comes in. So given that a student is a senior, the conditional relative frequency that they are not attending is about 32.4%. So percent-wise, if I look at 0.324 multiplied by 100, the chances that a senior is not attending would be 32.4%. All right, example 4, finding conditional probabilities. As I went to answer these, I realized I really needed some of these marginal relative frequencies written around the outside. So if you want to take a moment, I went ahead and I just added up the yeses. Oh, I'm sorry, let's go over what this is about first. A satellite TV provider surveys customers in 3 cities. The survey just asks whether they would recommend the TV provider to a friend. The results are given as joint relative frequencies are shown in this two-way table. So these are the locations of where people live, and then their responses would be yes or no. So we have the joint relative frequencies shown in the table. Again, I went and I found the marginal relative frequencies so that I could answer one of these questions over here. So I just added 0.29, 0.27, and 0.32 together to get the total 0.88. I added 0.05, 0.03, 0.04 to get 0.12. And then I also added columns 0.29, 0.05, 0.34, 0.27, 0.03, which is 0.3, and then 0.32, 0.04, which is 0.36. If I add the totals of the rows or the totals of the columns, I will get 1. So that's how I know that I have these totals written correctly. So the probability that a randomly selected customer who is located in Glendale will recommend the provider. So I'm going to write something over here, and then I'm actually going to do the work over here. So we're talking about probability. We're talking about probability that they answered yes, given that they live in Glendale. Okay, so that's the event. That's what we're finding. There's this given that, and I think it showed up on one of the first days of this, but we haven't done a lot of this conditional probability in here. I've had to trim down what we do since we're learning remotely, and we don't have time for everything. So I've trimmed down the conditional probability a little bit. But I do want to show you that there is a way that we will represent that with symbols. So I'm going to write the symbols over here. So color. We're going to write probability that they're going to say yes, given that. So the given that is just a line. Given that they live in Glendale, so we'll say Glendale. So if you see this line, that is saying probability that they would answer yes, given that they already live in Glendale. So this is a conditional probability saying they have to live in Glendale and say yes. So we cannot look at the Santa Monica, and we cannot look at Long Beach at all. So to do that, we are going to find the probability in this table here. We're going to find the probability that we have the Glendale and we have the yeses, and we're going to divide that by the total, which is going to be the probability of the Glendale. Okay, so over here we're looking at probability that they said yes and they're in Glendale divided by the total of the Glendale. So we're going to do 0.29 divided by the total of Glendale, 0.34. Okay. We divide that and we get, and I'm putting approximately because, these are probably rounded. I get 0.853. Okay. And to interpret that, what's the probability? You could say 0.853, or we could say this is about 85.3% probability that people live in Glendale. Oh, I forgot the 3. 85.3% that people who live in Glendale would recommend the TV provider. All right, and then question B. What is the probability that a randomly selected customer who will not recommend the provider is located in Long Beach? So we're going to use probability that they are a no, given that, no, I lied. Just kidding. I'll restate that. Yes, so we're going to, we're trying to find the probability that they are in Long Beach, so that's going to be the first part. Probability that they are in Long Beach. Probability that they are in Long Beach, given that they said no. Okay, so we're going to do the probability of just Long Beach and no on top, and we're going to divide that by the probability of the no's. Look over at our table. Probability of Long Beach and no is 0.04. And the probability of all the no's, you'd have to add all those up together, and we get 0.12. Okay, you divide that and you get approximately 0.333, and we take that into a percent, it would be approximately 33.3%. That would be the probability that if the person says no, that they are located in Long Beach. The question C, I haven't gone over at all, and probably will not, just because of timing. We just can't cover everything since we're on this remote learning thing. So we're just going to skip that. All right, so the last one is comparing conditional probabilities. So I'm going to, have you pause this, and I want you to go through and I want you to actually put the numbers in here. We are going to find the relative joint frequencies and the relative marginal frequencies, and then we're going to compare these answers to find out if we have a jogger that wants to burn a certain number of calories during his workout. We've got 3 different routes. We've got how many times he reaches his goal, how many times he does not reach his goal, and we're going to determine which route he should use depending on which, where he burns the most calories. So anyway, pause the video, and I want you to go ahead and find out the joint and the marginal relative frequencies, and then unpause the video, and we will talk about how you determine how we can compare these together. Okay, so I went ahead and just used a marker and, counted up how many tick marks there were for each of these boxes. And then I put the totals in there. For me, it's easier to see the totals. You don't have to put them in. So I found all the joint and marginal frequencies for this table up here. And then to find the joint relative and marginal relative frequencies, we're going to take everything in this table down here, or everything in this table up here, and we're going to divide everything by 50. So we're going to take it over the total. So that's what I did here. So I used my calculator. I divided all of those numbers by 50, and because they were divided by such a nice number, they only are 2 decimals each. So if you weren't sure what to do, I just took all the values here, divided all of them by 50. You can see my work in the top corner. And if you can't write these down fast enough, you can pause the video at any time to catch up. And 50 divided by 50 is 1. All right, we have to Determine which route would be best. Where does this jogger meet his goal the most? So what we're going to do is we're going to find the probability that he reaches his goal given that he takes a specific route. And we're going to compare those answers. So it's going to look like this. We're going to do the probability that he reaches the goal given that he took route A. We're going to compare that to the probability that he reaches his goal given that he's doing route B. And we're going to do the probability that he reaches his goal given that he's taking route C. All right, so reaches the goal. We're going to look in the reaches the goal column. Let's see. Reaches the goal 0.22 or 0.22. And we're going to divide that by, I'm so sorry, the total for route A. So 0.34. And I'm going to go ahead and type that in my calculator, and that is approximately 0.647, which is 64.7% of the time that he does route A, he reaches his goal. Same thing for route B. Reaches the goal is also 0.22, and route B 0.30. Type that in our calculator and we get approximately 0.733, which is about 73.3% of the time when he takes route B, he reaches his goal. And then for route C, reaches his goal 0.024. And we're going to divide that by the total for route C, 0.036. Oops, I don't even know why I wrote that. So just looking at how many, what's the chances that he reaches his goal in general, 0.22, 0.22, 0.24, it looks like route C is the best. But as soon as I type in 0.24 divided by 0.36, I get 0.667. So that's only approximately 66.7% of the time. So it really is conditional. It's really relative conditional about, compared to how many total times he calculated if you reached it or didn't reach it on that route. So if we look at this information here and we compare the three, route B seems to be the best choice. He should use route B to meet his goal the most amount. Okay, if you guys have questions, remember to come Zoom with me. I know that this stuff is not the easiest. It's not the easiest. So we can have a conversation together. So much easier to do it live, just talking, rather than trying to type out information and questions. So please come join me for Zoom if you have any questions.